This video is still in section 6.1, but I just wanted to point out a few more things before we end our conversation about this section. So I am looking at page 365. I do want to remind you, you have to memorize this arc length formula. I will not provide it during the test. You have to bring it in your brain, and you have to remember to note in your brain that the theta must be in radians. Also, I would like for you to see on page 366, when we're talking about going from degrees to radians, just another point out, a quick reminder that if you are degrees and you're going to radians, you're going to use the pi over 180 because we're trying to get the degrees units to cancel out, be removed, become 1, and we end up with an answer that has pi in it by reducing the numbers that are still remaining. When we are going from radians to degrees, we're not going to multiply by pi over 180. We're going to do 180 over pi because we're trying to remove, reduce, eliminate, whatever words you want to say, the radian piece, the pi piece, and end up with purely our number, and that'll get us back around to 30 degrees. But at the bottom of page 367, I do want you to see that there is a table, and I wrote down the words memorize. I'm not going to ask you on a test to have, we're not going to regurgitate this on a test, but you will find that this semester goes much more smoothly if you will memorize these simple degrees and radians conversions. Because if you memorize them, you don't have to go through that process I just showed you every single time. And so you might want to start with the quadrantal ones. Like this one's pretty nice. 0 degrees is 0 radians. 90. You might could have already guessed that, but I do want to take a second to draw a piece of that. Sometimes people get a little bit confused because they think, well, we're going to go all the way around this circle, and that's one whole time, and then half of it is half of its time. But when we're talking about radians, 0 is here, and a full pi is all the way over there, or 1 pi. And if 0 all the way around here is a full pi, then half that distance is going to be half of the pi, but we usually call it pi over 2 to be a little bit lazy. So right here you see 90 degrees is pi over 2. It's a half of this full pi. And then if you go on around past pi to the next half, that's 1 and 1/2 pi's. But we're going to do a quick combination of this mixed number, and we're going to call it 3/2 pi. And so this 270 degrees is 3/2 pi, and it's right here. You need to memorize that one. And then getting all the way back around to 360 degrees, we went a full pi and another full pi, and we need to always know that that one's a 2 pi all the way back around. We're going to get to a thing later called a unit circle, and I am going to ask you to memorize that. These pieces will be there, but you could still calculate them on the side. I say memorize them now. When you're looking back here at this quadrant, half the way is actually half of a half. And half of a half we're going to call a fourth, or a fourth pi is going to be what we call 45. And then all the way around they're going to be based on fourths for our 45s. Like when we get right here, I've gone 3/4 of the way. I've gone 5/4 of the way, because we're going to talk a whole lot about these. And if you already have them memorized, it's going to make it just a lot faster for you. The 60s are all going to have a denominator of 3, and the 30s are all going to have a denominator of 6. So I believe it's one more thing I wanted to talk to you about. We'll just use example 7. So I am looking at the top of page 369. And in your homework and on our test, sometimes it will say, leave your answer as an exact answer. Sometimes it will say, leave your answer as an approximate answer. You need to know how to do both. And so right here, in between my fingers, you see pi over 3. That's an exact answer. Pi over 3 is exact. Nobody's put it in a calculator. We haven't messed with the decimals. It is exact. And so when somebody asks you for an exact answer, and it may be better if I use pieces of paper, but you get the idea that it's going to be something that hasn't been punched in a calculator yet. But if they ask for an approximate, then you can start punching in the calculator, and then it'll tell you where to round. I just wanted to re-point out through all of my videos, his videos, read this, do this. I wanted to pull a couple of these pieces back together, and then also mention that the last thing I said on your note is that I need you to memorize these 3 videos, these 3 formulas, because these 3 formulas you're going to need to bring into the next test or first test in your brain and bring them in by memory. That concludes our section 6.1.